Children, having studied in the very first video what is reflection and how reflection of a point takes place along x-axis, y-axis and origin, let's proceed further now. Two things is what we are going to study over here in this particular video. One is invariant point and combination of reflection. So let's first understand what do you mean by invariant point. Invariant point, right? As the name suggests, invariant, which is not going to vary. So what's the definition? Says any point that remains unchanged. Any point that remains unchanged. You can also say unaltered. Any point that remains unchanged or unaltered under given transformation is called invariant. So in order to understand this more better, what we have done is we have taken a very small coordinate axis, x-axis, y-axis. On x-axis we have point A, 3, 0. On y-axis we have point B, 0, 4. So what if I have to take reflection of point A along x-axis? Right? Yes, in the first video is what we have learned was, in the first video we had learned there was a point in the coordinate system. We reflected that particular point in x-axis, we reflected that particular point in y-axis, we reflected that particular point in origin. Refresh your concepts then. Now what I'm saying is that point A lies on x-axis and I am reflecting point A along x-axis only. Do you think so the coordinates of point A will change? Answer is no. Point A, and if we were to say reflection is A dash, then point A and point A dash is going to be the same. So point A 3, 0 is said to be invariant point under the reflection in x-axis. If I take reflection of this particular point along x-axis, reflection will be the same point itself. Such points are termed as invariant point. If this happens with x-axis, the same thing applies to y-axis also. Say point B, 0, 4. So what is the example? This stands for example. Point B, 0, 4 is said to be invariant. When can I say this point is invariant? If it is under reflection in y-axis. Are you getting me? What is an invariant point? Right? So any point that remains unchanged or unaltered under given transformation is called as invariant point or simply invariant. Right, children? There are many questions being asked in board, right? Many a times is what they ask within your sum. Hence state the invariant points along so and so line of reflection. It could be x-axis, y-axis or any other line also. But yes, many a times is what in board papers, many times this particular question has come. Name the invariant points along so and so line of reflection. Right? We move further with combination of reflection. Now this is very important. Combination of reflection, that means a particular point is reflected multiple number of times. A particular point is reflected multiple number of times. So what is the first one trying to say? The first one says reflection of point P. Reflection of point P, whose coordinates are x, y, in y-axis. First, the reflection of that particular point P takes along y-axis, followed by reflection in x-axis. So first the reflection takes place in y-axis, followed by x-axis. How we represent them? We represent it first reflection. M stands for, My stands for reflection in y-axis, Mx stands for reflection in x-axis. We normally give annotations, denotations in this particular way. So reflection of a particular point P along y-axis, followed by x-axis. So the reflection which takes first comes first and which takes later on comes second. So don't you consider this is first. No, children. In reflection we go and say this is first followed by this. Right? This is not first. This is first. Reflection near to the point is taken as first one. We move further. So reflection of y followed by x of a particular point will be, we will take first reflection along y-axis. We are very much aware reflection along y-axis is x coordinate will change. So this mx stands as it is, my of the coordinate x, y. What is reflection along y-axis of x, y? Minus x, y. Reflection along y-axis, x coordinate changes. Y remains the same. So we are done with reflection along y-axis of that particular point. Now what? reflection of this one, which has already taken place under y-axis. Now what if it undergoes reflection along x-axis? Now undergoes along x-axis means what should change? Y coordinate should change. So my x coordinate remains the same, but y coordinate changes. Minus x minus y. Now children, if I start my first point was x comma y. Finally what I got is minus x comma minus y. So what is single transformation? We took two transformation along y-axis followed by x-axis. So what is the outcome, resultant outcome of a single transformation? Minus x minus y. Don't you think so that both the coordinate sign got changed? And if sign of both the coordinates happens to get changed, it is reflection along origin. That's what we have learned earlier. So what is minus x comma minus y is nothing but reflection along origin. So I have summarized in this box. Reflection of a particular point, first with y-axis followed by x-axis, is nothing but reflection of origin. So you can say this arrow signifies single transformation. This arrow signifies single transformation. Many a times this also is being asked. A particular point gets reflected multiple number of times under different lines, and the question is, what is a single transformation? Right? So reflection of y-axis followed by x-axis, single transformation is nothing but reflection of origin, is what the outcome is. On the same lines, we are going to work out the second one. Reflection of point P in x-axis followed by reflection in y-axis. Earlier we had y-axis followed by x-axis. Now we have first x-axis followed by y-axis. Now if you can understand the way in which it is being written. First x-axis followed by y. So on the same lines, children, mind you, it's absolutely on the same lines. Reflection of first this particular point along x-axis. Along x-axis what changes? Y coordinate changes. Now along y-axis what changes? X coordinate changes. Both the coordinate got changed. That means what is the single transformation? The single transformation. What is the single transformation, children? The single transformation is nothing but along origin. Single transformation is nothing but along origin. Again the same. Reflection of x-axis followed by y-axis is nothing but reflection along origin. So come what may, reflection in y-axis followed by x-axis or x-axis followed by y-axis, ultimately the single transformation is nothing but reflection along origin. What's the next one trying to say? Reflection of point P in x-axis followed by reflection in origin. So first x-axis followed by origin. So we take first MO, reflection in origin outside, reflection in x-axis, y coordinate changes, x comma minus y. Origin, both the coordinates should change. So x turns to minus x, minus y turns to y. Because under origin, both the coordinates ka sign changes. So minus x, x will turn to minus x, minus y will turn to y. But what is minus x, y? That means the x coordinate is getting changed, but y remains unchanged. That means it is reflection along y-axis. So what is single transformation? Single transformation of reflection of a particular point on x-axis followed by origin. Single transformation is reflection along y-axis. Same lines, children, on same lines. Reflection of a point P in x-axis. Earlier it was, in y-axis. Earlier it was x-axis. Reflection of point P in y-axis followed by reflection in origin. No change whatsoever. MO my of xy. MO my of xy. That is reflection along y-axis. X coordinate shall change. Thereafter followed by origin. Both the coordinates should change. Ultimately, if y is getting changed, that means the reflection is taking place along x-axis. So this is the single transformation. You can say this is the single transformation. Again written over here, MO dot my, that is reflection of y followed by origin, is nothing but reflection along x-axis. MO dot mx is my, reflection of x-axis followed by origin is reflection along y-axis. All the 4 points has been summarized. All the 4 points has been summarized. You can see that. Reflection of y-axis, don't start from here, children. Even if you have to by heart and summarize it, don't start from here, please. Reflection of y-axis followed by x-axis. Reflection of x-axis followed by y-axis is nothing but reflection along origin. Reflection of origin followed by mx. Here, whether you take mx ahead and mo behind, it's going to be the same. So mo followed by mx, or you can say mo followed by mx is my, as I stated. Anything can come first. Here also my.mo or mo.my is again mx. This is what we should know before we go for solving any single sum of reflection. We should be very much thorough with the first slide which we have done, and we should be very thorough with this particular slide. After understanding both the slides of reflection chapter, then and then only start doing and solving your sums. And if you are thorough with both those things and whatever we have learnt up till now, all the sums of reflections are very easy. Maximum sums of reflections are based on graph. Normally during the board exams, sums which are based on graph do appears more, almost 90-95%. Rare is what we see some kind of sums which are solved in your normal page. So maximum sums is what we are going to see in graph, right?